Cragside, in Northumbria, was the home of Lord and Lady Armstrong. Set in 1,700 acres of land, the house is surrounded by woodlands, gardens and 5 lakes. Built in 1863, Cragside was to become one of the most modern houses in the country, recognized by many as the palace of a modern magician. Born in the year 1810 at Newcastle on Tyne, William Armstrong trained as a solicitor in London, where he worked for several years as a lawyer. But his real interests lay in engineering, and particularly hydraulic power. He was inspired to a large extent by the historic use of water wheels as a means of converting the movement of water to create the power for industrial power. Lord Armstrong was a visionary, inventor, engineer, scientist and businessman. He bestrode the 19th century world like a colossus, bringing global renown to his great Elswick works, located on the north bank of the Tyne. Armstrong's company, founded in 1843, grew rapidly, eventually employing over 20,000 people in the design and manufacture of high-pressure hydraulic cranes. He also used hydraulic power to operate moving bridges, thereby altering the shape of Britain's industrial landscape throughout the century. Armstrong's skills and ingenuity didn't go unnoticed by the military. After being knighted in 1859, Sir William Armstrong became an armaments magnate and effectively chief gun manufacturer to the British Army. Lord Armstrong became Britain's largest industrialist and one of the wealthiest men in Europe. He was the first engineer, indeed the first scientist, to be raised to the peerage. Among his triumphs was his contribution to the original lifting gear for the Tower Bridge in London.
Hydraulics, the science of fluids in motion, was not new to the 18th century. Water-driven mills and pumps had been in use for centuries, but it was not until the industrial age and the invention of steam engines that water could be pressurized and accelerated at much higher rates than its natural flow. To build the biggest hydraulic machine of its time, John Wolfe Barry enlisted the services of Sir William Armstrong, one of the pioneers in the field.
William Armstrong was an inventor, he was a scientist. His own home had any number of hydraulic embellishments. You know, he could move his flower pots in his conservatory, he could turn his spit hydraulically.
The hydraulic system Armstrong and Barry developed would drive the bridge until 1976. It was powered by 2 pairs of coal-fired boilers and 2 steam-pumping engines, situated in the main engine room under the southern approach. While 360 horsepower may not seem much in the age of high-powered combustion and jet engines, in the 1890s these were among the most powerful engines available. The steam engines pumped out water at a pressure of 750 pounds per square inch. This pressurized water would be driven into 6 accumulators to store energy for moving the bridge. The accumulators were essentially vertical metal tubes. 2 were housed near the machine room in the southern approach, and 2 in each of the piers. A huge piston weighing 100 tons, as much as 2 battle tanks, acted as a pressurizing weight on top of each of the accumulators. The steam engines forced the pressurized water into the accumulators, pushing the pistons 35 feet up. Then, valves at the cylinder base were shut to prevent backflow, and the piston weights kept the water under pressure until needed. In its first year of operation, an average of 8,000 horse carts and 60,000 pedestrians crossed the bridge each day, with an average 17 lifts for shipping traffic. According to the Act of Parliament of 1885 that allowed Tower Bridge to be built, shipping would always have the right-of-way and never be impeded. To facilitate this, the bridge had to be operational 24 hours. Today, the massive bascules of Tower Bridge are raised on average less than twice a day. The ocean-going freighters of old have long given way to tall-masted yachts and pleasure boats entering the upper pool. But Tower Bridge still shines as the proud portal to the City of London, a testament to technical ingenuity and the glory of a bygone era. It welcomes all who arrive here, be it by ship or by tour bus.
Meanwhile at Cragside, Lord Armstrong's engineering skills and passion for hydraulic power are evident in the various labour-saving gadgets around the home, some to aid household staff. In later life, Lord Armstrong set about a new challenge, one that he had in mind for some time. The year was 1878, and the time was right to consider introducing electric light to Cragside. This was made possible by bringing together his experience with hydraulic power and the development of the electric generator. A dam was built to provide stored water which was then fed by gravity into a header tank, sited on the roof of a powerhouse building. In this powerhouse, Armstrong positioned a 6-horsepower turbine to power a hydraulic pump. The pump provided a controlled water supply to the house and the devices within. A Siemens dynamo was later coupled to the turbine. Electricity was now available to power the newly installed carbon rod arc lamps situated in the picture gallery. It was not too long before there was an increased demand for electricity in the house. This prompted the construction of a second powerhouse. The Burnfoot powerhouse, constructed in 1886, was equipped with a Gilkes turbine and a Crompton generator. The turbine was powered from Nelly's Moss Lake, located around 104 meters above the powerhouse, creating a pressure of 150 pounds per square inch at the turbine. 45 new lamps had been installed in the house. These were of the incandescent type, perfected by Sir Joseph Swan. Visitors travelled from miles around to see how the power of water had been converted into electric light. Today, visitors to Cragside House and Gardens, now owned by the National Trust, can see for themselves the wonder of technology as it was in Victorian times. As a visitor, you will also see the care and attention afforded to the contents of the home and surrounding land by the Trust. The gardens were originally established by Lord and Lady Armstrong, with the prolific planting of trees and shrubs. Formal gardens are abound, and there are now 40 miles of walks. The house itself overlooks one of the largest rock gardens in Europe. As you wind your way along corridors and through the rooms at Cragside, you can't fail to notice the very particular designs of William Morris. Morris is widely regarded as the father of the arts and crafts movement, the style in which Cragside is decorated. This movement was a British design phenomenon, begun as a response to the increasing industrialization happening at the time. It was felt that the true hand craftsmanship involved with interior design was being lost amid new mass production techniques. Cragside has a sizable collection of stained glass, supplied by the William Morris Company. In the library are designs by Dante, Rossetti, and Burne-Jones, all supplied by Morris. More Morris glass can be seen on the stairs to the gallery. Morris's first wallpaper designs were drawn in the 1860s. In fact, the wall covering, birds and trellis, in the White Bedroom was among the first commercial designs. The rooms here are in fact decorated with reproduction wall covering, printed from the original wooden blocks. After samples, dated 1863, were found in the house. The arts and crafts movement was perhaps an unusual choice for Armstrong, given that he was a leading industrialist of his day, and the movement was essentially anti-industry. Sir William Armstrong died on the 27th of December 1900, at the age of 90, just a few weeks before the death of Queen Victoria. The Times newspaper said in its obituary, "With his death, Newcastle loses her greatest citizen, and in the country at large, one of the worthies of this century." However, the legacy of the modern magician lives on, with the continued use of hydroelectric power, both at Cragside and on a much larger scale around the world.